In this video, I want to talk about accuracy and precision. And these are two words which pupils tend to always get mixed up and get a little bit confused with, and they can be used interchangeably. What's important to remember is that an investigation, a practical, can have a high level of accuracy, but also a low level of precision. And likewise, a low level of accuracy and a high level of precision. So it's just going to have a quick overview about the differences between the two. But first of all, let's start with a very simplified version of what we might be looking at when we talk about accuracy and precision. So to be accurate, all right, you quite often read definitions about having it's close to the true value. Basically, what that means is that they are on target to what they should be. So if you're doing a heat capacity experiment to find out the heat capacity of aluminium, then you'll be accurate if your results are close to 900, all right, joules per kilogram degrees Celsius. Now, so what we do when we look at this is to get a high level of accuracy, what we have to do is make sure you've got a high level of skill set by following a detailed method closely. So making sure that your method is correct and you use the right equipment, potentially to do as well with the resolution of your equipment. Now, I've done another little video about the resolution, about what that means and some example questions. If you're not sure the meaning of that word yet, please look at it, because again, that's a concept that pupils tend to get mixed up with. And we've got to associate with this is a type of error that is a systematic error. So a systematic error are errors quite often to do with equipment. And these are errors that are seen throughout the investigation. Now, for precision, to have a very precise experiment, this means there's going to be little variation in your repeats. So the repeats that you do in the investigation show little variation. And again, you need a good detailed method that you follow through with the fine details. But the type of error they want to reduce here are random errors. Now, random errors, again, they're errors which pupils quite often tend to write human error. We don't want to write that. We want to write random error. And they're the type of errors which potentially are caused by human error by not taking care, say, in reading your measurements. Now, these will mean that when you look at your data set, that when you do your repeats, sometimes they don't fit the pattern or trend. And that's because of these random errors. So when we look at this, we quite often see a nice little dartboard. And it's a really good example of a way to how to look at these examples. So let's have a look at this first set. So let's have a look at a high level of accuracy, but we're going to have also a high level of precision. So it's going to be very precise and very accurate. And this would be when our darts hit the bullseye all together. You can see they're really close together, so they're precise and they're on target. They've hit the ball. Now, what about if we have a high level of accuracy, but a low level of precision? So they're going to be accurate. So they're going to be near enough around the ball because they're going to be on target, but they're not going to be precise. They're going to be a little bit around that target. Now let's have a look at a practical that is not very accurate, but the data is really precise. And our results for this will be way off target, way away from the ball, but they're going to be close together. So you can see they're close together in this scenario, but they're not on the bullseye. And what about if we have a low level of accuracy and it's not very precise either? In this scenario here, they're going to be all over the place. So I hope that makes sense. Now we can also look at it in another way. Let's say you're taking some penalties at a goal. Now obviously the aim of this is to score a goal, and you'll be accurate if you get it between the sticks. So a quick goal. Alright, so to get the goal you need to get it in the sticks. Now if you had a high level of accuracy and you're precise, you would score 3 penalties, and all of those shots, say, will be top bin. Oh. So we get it in top bin all together. Now, what about if let's just change this pen colour, had it with a high level of accuracy but a low precision. So this one means that accuracies are all going to be scored, but they're going to be all over the place. And let's take a look at a low accuracy but a high precision. So in this case here, they're going to miss the target, all right, but they're all going to end up in roughly the same place. And lastly, they're not going to be accurate and they're not going to be precise. So one might hit the post, one might go over the bar, and one might hit a poor fella in the stand over here. So I hope that goes some way of explaining the difference between an accurate experiment and a precise experiment, and the differences between them. You obviously want to get a practical, which is along this lines here. And to do that, you need a good skill set, follow a good method, use the right equipment, make sure there's no errors like 0 error or systematic errors there, and you reduce the amount of variables that go wrong. Yep, and you do lots of repeats and you get a mean, you get an average. I hope that helps explain the difference between the two. And like I say, have another look at the video on resolution and see how that ties into this. This is really important for all of your sciences at GCSE and A level to understand. Good luck.